In this video, we'll show you how to program Robot PU to perform Kungfu and Taiji. Kungfu Taiji. When the servo moves at full speed, it looks like Kungfu. When the servo moves slowly, it becomes Taiji.
Now I'm going to show you how to use motor program to control robot go to each position. First, let's create a new project. Say test moves. And we create an object. Then we're going to load robot Fuse extension. And press that. And after we load the robot Fuse MakeCode extension, as you can see in the actuator section, we can find this server moves. There are two kinds of server move. One kind it is move to position immediately. The other one is called move to a position with step size. That means you can move to a position progressively controlled by a speed. The speed it is controlled by the step size. All the unit here it is in degrees. Now you might wonder what is actuators. Actuator is all the devices that can change this wall, like a motor, speaker, anything make the wall different. It's actuator. And the servo is one of them. Okay. Here I'm going to show you how to the first command, move to a position immediately. In order to use this move, you need to do a pause. And the pause, you can find a pause command at here. Basically, you send out a command. Say, for example, you move the left foot position into 90°. Then wait for, say, usually it takes about half a second to reach a position. So then you can, for example, if you do this two moves in a forever loop, say move to 90°, left foot to 90° and left to 45°, then when you run this program, the robot will raise its left foot and stop its that and put the left foot on the ground. When you say the left foot to 90°, that means the left foot it is lay flat on the ground. When you set left to 45°, the left foot will tilt it. And when you put those four commands, move, pause command in a loop, and the robot will keep doing the tiptoe thing. Okay, so in order to usually when you make a robot move, you not just move one joint. As you can see at here, our robot P has 6 degrees of freedom. You can move the left foot, left leg, right foot, right leg, head yaw, and head pitch. So in order to make a robot pull, move, dance, jump, you need to define all those 6 angles. Okay. Here is an example. Say this is robot position. Look at this table. If it's a stand position, then all the servo it is 90°. Okay, that's we call it neutral position. If you want robot P to jump, then you can see we change the angle of left foot and left feet and right feet. Okay. If you make robot P to duck, then you need to move the both foot to extreme position, because it's 0 and 180. Okay. Yeah, if you want to do a calibrate, then that's the angle you move to. And the other interesting thing is if you want to do a side step of robot view, then you need to call this position first. Then after a couple seconds, you call this position. So basically, you need to do a side step move 1, then call side step move 2. Okay. Now let's implement something interesting. It's called robot view jump. So in order to jump, you need to stand first. So that means the first position you want robot P go to, it is stand position. After fraction of seconds, you make the robot to jump. After jump, you make it to stand. So basically the jump movement is stand, jump, stand, jump, stand, jump. Then we're going to, here, we're going to write a program to do it. Okay, so the other thing we want to mention, it is the functions. In order to make things easier, so you need to write a stand function. Okay, then you need another function called jump function. Okay, so as we can see, the reason we want to implement it as a jump and a stand, it is we can reuse those commands and put in a forever loop. For example, at here, that's the purpose of functions. So basically, you wrap up a complex command set into one function and call a function in a loop, such that you don't have to copy and paste the complex code everywhere to make your code really big. Okay, so let's do this. Okay, so basically this is in order to jump. Basically that's the thing we need to do. Call, jump. Okay, first you stand, pause for half second, then do jump, then loop back to do the stand and jump again. Okay, so and let's implement the stand function. We need to implement this all 6 degrees of freedom, right? So at here, then we need to copy and paste, right? Quite a bit. Say you move left foot to 90 degree, and move left leg to 90 degree, move right foot to 90 degree, and move right leg to 90 degree, and move head yaw to 90 degree, then move head pitch to 90 degree, right? So and the jump function, so you need to do quite similar thing. The jump function is 130, 90, 50, 90, 90, 90. Okay, so if you really want, you can make head pitch to be 30, so you will raise the head. So now we have a program to call stand and jump function in a loop, and we are going to see how robot Pew jumps in this way. Now let's load the program. This is how robot Pew jumps. As you can see, it loops through the stand position and jump position. Now let's change the servo angle a little bit and see something interesting happen. For example, now let's look at some code changes. We introduce a new concept called move with a step size. There are 2 step size functions. First one, it is if you want to do graceful movements, then you need to move server step by step with some step size. And here we're going to show you how to make a graceful yoga, because at here we implement a while loop. We call server step right leg function. We move to this 170 degree with a step size 0.05. If the magic function logic here, it is if the server haven't reached 170 degree, it will return not 0. And if it's reached 170 degree, it will return 0. So if you put this function inside a logic function and put in a while loop, the robot Pew will keep moving in each for loop. It will move small step size until it reaches 180 degrees. So in that case, robot Pew will do graceful movements. As you can see here, we make the yoga position 2 and 3 to do graceful movements. Let's see how Robot PU works with this code.
Let's do Taiji with robot PU. White crane spreads wings. Grasp the bird's tail.
Robot gyms.